Okay, all right, again, today we're going to cover 2.6 and 2.7. So 2.6 is all about solving absolute value equations. Okay, so a couple of things we need to talk about. First off, absolute value. Absolute value as a symbol are these vertical straight bars. Okay, and what these vertical bars are saying mathematically is that is the distance a number is away from zero. So absolute value of 2 on a number line, okay, if this is 0, the number 2 is 2 units away. So the absolute value implies a positive 2. The absolute value of negative 2 implies that this is also 2 units away from 0. See, direction doesn't matter. It doesn't matter if you're going right or if you're going left. Absolute value is just a distance. Distances go in different directions, but they're always positive. Okay. You don't say you're going negatively to Springfield from Lebanon and then positively if you're going to Raleigh from Lebanon. Okay. So distance is just distance regardless. So the absolute value implies a distance. So this is a positive number as well. So absolute value bars, these vertical bars, take whatever is inside and then makes it positive. Okay. So whenever you go to check your stuff, whenever you're plugging numbers in, just remember that everything inside of the absolute values is then positive. Okay. Also, absolute value does not affect any numbers going on outside. So if I said 3, absolute value, well, let's do -3 absolute values of 2. The absolute value of 2 is still 2. And then -3 times 2 would be a -6. So the absolute value only affects what's inside. The absolute value of 2 is 2, but this -3 outside is unaffected by the absolute value. So anything going on outside is unaffected. All right, so first off, that's the concept of absolute value. Now we're going to talk about solving some equations, meaning they're going to throw some letters in here. So we'll start out with something basic that we pretty much just talked about already, right? So if I said the absolute value of some number is 2, okay, what numbers could I plug in for x that would make this work? Okay, 2 or -2, either one. Because if I plug in a positive 2, I get a positive 2. If I plug in a -2, I also get a positive 2. So to solve the absolute value of x equals 2, x could equal positive 2, or x could also equal -2. So with absolute value equations, there is always potentially 2 answers. Now I say potentially because there's the possibility that you could have no answers, or there's a possibility of 1 answer. Okay, but there's always the potential for 2. Okay, we can account for both the positive and the negative. Now, to get those answers, these are kind of the steps we're going to follow. But the first thing we have to do is isolate the absolute value. So that means getting this vertical bars, get it by itself. Anything that's going on outside, we've got to get rid of it. Okay. Once we have that absolute value by itself, this is where we're going to split it up. Okay. When we split it up, we're going to split 1 into the positive and 1 the negative. And I'm going to do some examples of these so that makes a little more sense. But again, you're going to have to account for both a positive and a negative value. And then you will solve those equations individually. So we're going to walk through some problems more along the lines of what you're going to see whenever you get into MyMathLab. This is the most basic possible problem you could be looking at. We're going to have more stuff going on. All right, so the first problem I want to look at is one where we've got more stuff going on. So let's say we've got the absolute value of 2x plus 1 minus 3 equals 7. All right, to solve an absolute value equation, again, we need to get this absolute value piece by itself, meaning we've got to get rid of anything else going on. So for example, this minus 3, we got to get rid of it. When I say to get rid of, all right, I'm talking standard equation solving techniques. So standard equation solving techniques, the opposite of a minus 3, or to get rid of a negative 3 here, we're going to add it. So we can add 3 to both sides.
Please.
So the absolute value of 2x plus 1, and then 7 plus 3 equals 10. So now we've got the absolute value piece by itself. Now, when I talk about splitting it up, this is what I mean. We're going to take this 2x plus 1. We're going to set it equal to the positive value of 10. We're also going to take the same 2x plus 1. So again, whatever's inside of your absolute value doesn't change. We're just going to change the value of what it equals. So we're going to set this one up to equal a negative 10. Okay. So then we've got two equations that we need to solve. Subtract 1 from both sides, divide by 2, and x is going to equal 9 halves. That is one possible solution. Solve the other one in the same manner. To get rid of the plus 1, we're going to subtract. So 2x equals negative 11. Divide both sides by 2. X could equal a negative 11 halves. Now, when it comes to me grading a problem like this on a test, it's probably going to be worth the 3 points. 1 point for showing work, showing me you know how to split it up. 1 point for this solution, and 1 point for this solution. MyMathLab tends to just do things all or nothing, so they'll just give you the points, yes or no, whether you got one right or both right. So be aware of that. Another thing to be aware of, MyMathLab, when you type it in, they're going to give you some squiggly brackets. There's going to be a box in here. When you type in the box, you'll just type in your answer, put a comma, and then type in your other answer. So for MyMathLab, that's what they're going to want. So again, this is going to be inside of a box. Type in your answer separated by a comma. So just that way, if you get the right answer, you're not losing points based off of an entry error or whatever. So that's what they want online. So again, when you're doing your homework, again, for me personally, like this is what I want to see. This is good stuff. MyMathLab takes it a step further, just so you have a place to put your answer. It wants the set of answers, and that's how it wants you to type it in. So you're going to type it in separated by a comma, just so you know.
Wouldn't you add the negative if it asks that?
Oh, yeah, I'm sorry. Just like I always had from the very beginning and didn't forget to write down. Yeah, so negative 11 halves needs to stay negative. Thank you. Okay, I'll do another example. All All right, so say we have 3 times the absolute value of x plus -4 plus 1 equals 16. Okay, again, when solving, a couple of things I want to point out. The absolute value does not make this 4, this -4, it does not make it positive right away. Okay, once you know what x is and you go to plug it in, we can do the math, and then the absolute value will take whatever this number is and make it positive. But it doesn't make this -4 or a -4 positive right away. So I'll show you what I mean by that whenever we work through this. Just some people see these absolute value bars, are like, oh, this is going to make it positive, so it's going to take a minus and make it a plus, or take this -4 and make it positive. It doesn't do that until we know what x is. Okay, figure out what this number is as a whole, and then it would make it positive. So anyway, still, we want to get this absolute value by itself, which there's no difference between x plus -4 and x minus 4. It's just a rewriting thing. But we got to get rid of this stuff outside. So again, just like equations, to get rid of the +1, we're going to subtract. So again, to get rid of the +1, we minus. Do that on both sides. 16 minus 1 is your 15. Now, another thing, absolute values make everything inside positive, but it doesn't affect the stuff outside. So you can't distribute in. Some people try to take this number outside and distribute in, just like with parentheses. That's bad math. We can't do that. So if we can't distribute in, how do I get rid of multiplying by 3? What's the opposite of multiplying by 3?
Divide.
There we go. So you got to divide everything by 3. And again, do that to both sides. That gets rid of that. There we go. And you got to do all of that stuff first, because again, step 1, you got to isolate this absolute value. You got to get it by itself with nothing going on over here. Okay. So this 3 being multiplied and this 1 being added, you got to get rid of that stuff first. Then we can split it up. Okay. And like I said, when I split it up, the x minus 4 stays put. Whatever is inside of the absolute value is unchanged. Those stay the same. What you change is what it equals. So this value is going to equal +5, or this value is going to equal -5. Okay, so the 5, this number over here on the outside, is what becomes positive or negative. Notice what's inside of the absolute value is unchanged. Solve. X could equal 9. Or x could equal -1. Now, you don't have to, but I think it's a great idea to check your answers. You can check your answers. What you do is you plug your number in for x in the original equation, wherever you started. So I'm just going to rewrite this, but I'm going to plug my number in. So I've got 3, absolute value, 9 plus -4 plus 1. And then I'm not going to write the 16 here. I just want to see if it, like, I guess I can write 16. I just want to see if it equals 16. So 9 plus -4 is 5. The absolute value is 5. Three times 5 is 15, plus 1 is 16. So that one checks out. So 9 is a valid solution. It checks out.
Do you want us to show that?
No, 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 no. No need to show. I'm showing this as a check to
Okay.
see if you got your answer right. You do not have to check your answer.
Could we, okay, on our test, could we do it to check?
Oh,
to make sure?
definitely. Yeah. Anytime you have an equation, you can check your solution.
Okay.
And that's a good idea to check, but you do not have to. It is not mandatory. Okay. But you can. If you did the math right, this answer should check out. but we can check just to see. So again, okay, -1 minus 4 is -5. Again, the absolute value of -5 is positive. So 3 times 5 plus 1 is 16. So again, that one checks out too. And again, I was just showing that you can check your answer. You do not have to. All right, 2 other problems I want to look at as far as this section goes. Okay, let's say I have the absolute value of 3x plus 4 equals 0. Anytime you have an absolute value equaling 0, this is going to be a problem where you're only going to get one solution. Okay, so we have the absolute value by itself. We don't have to worry about getting rid of anything. So we're just going to split this up. But in this case, we don't even really need to split it up because there's no such thing as -0. 0 is a neutral value. It is neither positive nor negative. It's right there in the middle. So there's no need to have -0. This is unnecessary. So when you have it equal to like a number, 1 or 2 or 3, you need to solve for the possibility of a +1 or a -1, or a +3 or a -3. But with 0, there's no such thing as -0. So this is unnecessary. So we just have one equation that we need to solve. Now, even better, and I like when they do this because it's really easy, it's easy to grade, 2. If they give you a problem like this, you need to be paying attention. Very specifically, we talked about this at the beginning. What do we know about absolute value? By definition, this value has to be what?
A positive,
It has to be a positive number. What is this number?
a negative,
Negative. Can an absolute value ever equal a negative value?
yes,
No,
no,
no. This is impossible. There is no way this will work. There is not a single thing that you can plug in for X that will make this absolute value equal -3. Nothing will work. Decimals, negatives, imaginary numbers, it doesn't matter. There is nothing you can plug in for X that would make this work. Absolute values are always positive. Negative numbers are always negative. A positive number does not equal a negative number. There is no way for this to work. So this is a straight up no solution problem. It is inconsistent. This is a symbol that means the empty set. What this means is there is no solution. So if you ever have the absolute value equaling a negative number, it's the 0 with a slash through it. That means a no solution problem. It is not possible.
on the quiz, do you want us to write it like that, or can we write no solution?
You can write either or, both are fine. I know on my math lab, there's a button you click, that'll be for this one. They'll actually give you 2 specific options. You highlight the one that has the 0 with the slash through it. The other one will be the brackets with the box you're going to type in.
I have a quick question.
I have a quick answer.
Backing up to the previous problem really quick, I see that you are leaving them as fractions, obviously because you can't reduce 4/3, correct?
Correct?
If we come to a fraction that can be reduced, do you want us to reduce it on the test, or can we leave it as the bigger fraction?
No, you need to reduce it. If a fraction reduces, you need to reduce it. Now, improper compared to mixed, for example, some people's calculators will change -4/3 to -1 1/3. That's up to you. These are both fine.
I've lost audio.
Pardon? Okay, so -4/3 compared to -1 1/3, these are the same. I don't care there. But let's just say for example, okay, magic hand waving, we ended up with x equals 10/30. Okay, those are both divisible by 10. We would need to reduce that to 1/3. So if you can reduce, yes, you do need to reduce your fractions. Okay, I don't care improper or mixed, but if it does reduce, you need to reduce your fractions. So yes, reduce if possible, or simplify, however you want to say it. Okay, good question. And my math lab will remind you too, for example, if you type in 10/30, it'll give you a cue that says your answer is correct, but it's not in the simplest form. So that typically means you just need to reduce your fraction too. So, but yeah, if it's a fraction, you do need to reduce it. Now, back to this where an absolute value equals a negative. Don't jump to that conclusion right away. Make sure the absolute value is by itself. For example, they may throw a problem in that looks like this. Okay. The absolute value of 3x minus 5 equals -1. If you're too quick on the gun here, you can see all these negatives and be like, well, I know an absolute value can't equal a negative. That's a no solution problem. Hold on, because remember, what do we got to do with this absolute value? We got to get it by itself. So how do we get rid of this -5? Plus 5. And whenever we plus 5 to both sides, we end up with a positive number, and now this is solvable. So make sure you get the absolute value by itself first, like it was here. Then if it equals a negative number, there's no solution. If the absolute value equals a positive, then you can split it up and solve. So again, we would solve this. 3x would equal 4, or 3x would equal -4. So x would equal 4/3, or x would equal -4/3.
You have one student that lost audio.
Yeah, I saw. He said something, but I don't have a button. If everybody else has audio. Now, I am going to do one more example. My math lab likes to throw some problems with fractions in. If he goes back and watches the video on YouTube, the YouTube video will have audio as well. So if you lost audio, I apologize. But again, I want to do one problem. I have notes all over. Okay, so if they throw in a problem involving fractions, again, you've got a couple of options here. The rules and the steps are still the same. So if I got the absolute value by itself, this is where I can split it up. And again, what's inside the absolute value, I didn't change. So 2x minus 5/3 is the same for both. The 7, I've got a positive and I've got a negative. So these are the two that I'm going to solve. All right, I'm actually going to show you a couple of different ways to solve this. So just kind of bear with me. I'm going to solve these. They're obviously the same. You see the 2x minus 5/3, even though it went out of focus. Okay. So I'm going to solve both of these, but I'm going to do them both in different ways just to show you that you can do both. The best way, in my opinion, to deal with fractions is to get rid of them. So again, anytime you have fractions, I multiply by my lowest common denominator to get rid of the fractions. So I only have one denominator, it's 3. So if I multiply everything by 3, that gets rid of my fractions. For example, if I take 3 times 2x, I get 6x. 6x divided by 3 is just 2x. Same if I take 3 times -5, that's -15. Divided by 3 is -5. And then if I take 3 times 7, I get 21. So if I just do this one step, that gets rid of my fractions, and now I've got a problem to solve with no fractions in it. 21 plus 5 is 26. Divide. X could potentially equal 13. Now, another way to solve basically the same thing. So this 2x minus 5 over 3, because it's the same, I'm going to solve it, but I'm going to use a different method just to show you another way to do it. I like this one better, but this totally works. Some people like to split these up, so you can do 2/3 x minus 5/3 equals -7. And then you can just use your handy dandy calculator to solve this. Because your calculator probably has a fraction button on it. Of course, I don't have my calculator, so I get to do it freehand. So anyway, we add 5/3 both sides, and 2/3 x will equal, so -7 would be -21/3, so that'd be -16/3. And then you could divide by 2/3 or multiply by the reciprocal. 3's cancel, x would equal -8. To me, this is a more convoluted process. And instead of getting rid of fractions, it kind of invites more possible complications. To me, this is a much more straightforward method, but to each their own. They both work, okay? And still you can go back and check your solutions. But don't be scared of fraction problems. One step at a time. As you do one thing, it just makes it solvable. So I showed you a couple of different problems. Some had 2 solutions. If it equals 0, there's potentially 1 solution. If it equals a negative number, then there are no solutions. But that's basically 2-5. So that's going to be solving absolute value equations. Or, sorry, that was 2-6, right? 2-7 basically combines the previous two lessons. So 2-7 is solving and graphing and interval notation of absolute value inequalities. So we're going to be solving and graphing and interval notation. So again, inequalities is what we did last time. I believe that was 2-5. That was linear inequalities. These are going to be absolute value inequalities. So I'm going to start with the concept, fairly simple, and then we'll do some of the more complicated problems. Okay, and inequality is always going to be a less than or a greater than or a less than or equal or a greater than or equal to. Okay, and just like solving inequalities, it's basically the same rules as solving equations. You want to get the absolute value by itself. You're going to split this up into the positive and the negative. But if you'll also remember, inequalities had a different rule. If you multiplied or divided by a negative, that flipped your sign. So for the negative one, so notice the x is less than 5, nothing changed. We basically just grabbed this problem and dropped the absolute value bars. For the negative one, your sign is going to flip. It goes from less than, it flips to a greater than. So make sure you flip your inequality sign when you take the negative value. Then, like I said, we need to be able to graph these. So on a number line, again, it's important, smaller number has to go to the left. So -5 is smaller than +5. Come on, zoom in, focus, you can do it. Okay. +5 is the larger number. Okay, so larger numbers go to the right, smaller numbers go to the left. It's really easy to get those accidentally flipped up because again, we got pretty much the same number, but the negative one's over here on the right and the positive one's over here on the left. Make sure when you put them on your number line, the smaller one goes to the left, bigger one to the right. Next, open dots or parentheses, because these are not included. So less than and greater than. Okay, we do not want to include these numbers. And then you're going to shade. Absolute values will either shade in opposite directions or shade together. In this case, we want everything less than 5, which would be over here, and greater than -5, which would be everything in here. So we're talking about all of the numbers in between -5 and +5. So anything outside, anything smaller than -5 is no good. Anything bigger than +5 is no good. Interval notation comes straight from the graph. Open dots or parentheses stay as parentheses. Since we're talking about everything in between, it's going to look like that. This is the graph. Okay, this is what we call interval notation. We talked about this last time when we talked about 2, 5. It's the same, just now you're going to have typically 2 numbers instead of 1. It's kind of like those and or problems. So just looking at a problem like this, you can see they're going to be worth quite a few points. You're going to have a point for the work, typically a point for one solution, a point for the other solution, 2 points for the graph, okay, parentheses or brackets, shading in the right direction, 2 points for the interval notation. Smaller number to the left, bigger number to the right, correct notation, parentheses or brackets. Lots of points to be had here. Make sure you can solve and graph these. All right, same, I'm going to pick another simple problem just to kind of talk about a concept again. So let's say we had the absolute value of x is greater than or equal to, say, 3. Doesn't matter. Okay, again, when we split it up, x is greater than or equal to 3. Or, again, remember when we make the value negative, take your sign and it's going to flip it. Greater than or equal to becomes less than or equal to. Okay, again, on my number line, smaller number to the left, bigger number to the right. In this case, they're included, greater than or equal to, less than or equal to, so we want to use our brackets. And smaller than -3 is this direction. Bigger than +3 is this direction. So, like I said, absolute values will either shade together, like this one, or they shade away from each other, like this one. So in other words, every number smaller than -3 or every number larger than 3. Nothing in between. If you try plugging a number from in between, that's not going to work. The interval notation, this one is kind of goofy looking. It's going to go from -infinity to -3. And again, the bracket we're going to keep. And again, we use this symbol. It's the or that represents the gap. Then we're going to go from 3 to infinity. And you'll type this in just the way it looks. Okay, you're going to need to use your keyboard. So next to the P button on your keyboard is where you'll find those squared off brackets, parentheses. You should know where they are. This U looking button, do not use the U button on your calculator. That's going to be an on-screen button on MyMathLab. And if you'll remind me in just a minute, as we get closer to the end of time, I'll share a screen and I'll actually walk through a practice problem where we've got to type it in just like this. I'll show you how to type it in. But this is the interval notation for a shade away problem. So from negative infinity, infinity always gets parentheses. And then the number gets either parentheses or brackets, whether it's equal to or not. Just greater than or less than is parentheses. Greater than, equal to, less than, equal to gets the brackets. Now, I'm going to do two more simple concept ones, and then we'll do some a little more difficult practice problems. And it again deals with negatives. Okay, two different problems. Again, I keep grabbing the same numbers just because it's easier than messing with something different. But again, concept, absolute values are always positive. Negative numbers are always negative. Can a positive number ever be less than a negative number? No. Okay, that is false. Positives are always bigger, hence on the number line, positives over here. A positive number cannot be less than a negative number. This is a no solution problem. If MyMathLab wants you to graph that on a number line, nothing gets shaded. If there is no solution, you don't shade anything. It's just blank because nothing works. It doesn't matter what you plug in for X, this is going to make it positive. It doesn't matter what you plug in for X, this is always going to be negative. Positives are never less than negatives. Flip that. This is a positive. This is a negative. Are positives greater than negatives?
Yes.
Yes, every single time. So this is the other way around. This means everything works. All the way to negative infinity, all the way to positive infinity. Everything works. So again, on a number line, then everything gets shaded. So in concept, absolute values less than, pretty much going to shade between. Absolute values greater, straight away. If you're looking interval notation. If an absolute value to a negative number, remember, it matters which way the arrow is facing, okay? Positives are never less than negatives, no solution. Positives are always greater than negatives, all solutions. This is the correct interval notation for all solutions. This is the correct graph for all solutions. Everything gets shaded from negative infinity to positive infinity. Otherwise, everything is the same as what we were doing with the equals, just you've got to do the graphs and the interval notation. I want to walk through a couple of examples that we got to work out, and then I'll actually show you one on MyMathLab. And then that'll be that for tonight. So let's say we needed to solve something like this. All right, so we've got absolute value of 2x plus 3/4 minus 6 is less than or equal to -2. Now, again, this is just like that one example I showed you. People who are really quick on the gun see the negatives. Oh, look, absolute value can't be less than a negative, and they'll take this and make this a no solution problem. Remember, before you go doing that, you've got to get the absolute value piece by itself. which again, in this case, I need to get rid of this -6. So how do I get rid of a -6? We're going to plus. That's going to take my negative and make it a positive number now. Now this is a solvable problem. All right, so we're going to split this up. Again, whatever's inside the absolute value is going to stay. And then the positive one, everything stays the same. The negative one, make sure you flip the sign. So less than or equal to becomes greater than or equal to when we make that for a negative. So remember to flip your sign. Okay, again, I don't like dealing with the fractions, so I'm going to cancel them out right off the bat. So I'm going to multiply by this lowest common denominator, this 4 that I have on the bottom. I'm going to multiply to get rid of it. So 4 times 2x is 8x. 4 times 3/4 is 3. 4 times 4 is 16. Subtract 3. 8. X is less than or equal to 13/8, or 1 5/8. I think it's 1.625 as a decimal. Do the same thing here, get rid of my fractions, distribute. Four times 2x is 8x. 4 times 3/4 is still 3. 4 times -4 is -16. Subtract 3 from both sides. Divide 8. X is greater than or equal to 19, or -19/8. So you get a point for the work. There will be 1 point for this answer, 1 point for this answer. So the good news is anything you get right, you get points for, okay? So if you make one little bitty mistake, you're not going to lose everything. The bad thing is there's lots of different places to mess up a problem like this. There's lots of stuff going on. So take your time. Don't make any silly mistakes. All right, when we graph this on our number line, again, important, smaller number has to go to the left. I like when one's negative and one's positive because the smallest one is obvious. The negative number is smaller than the positive number. So make sure the smaller number goes to the left, bigger number goes to the right. Okay, in terms of shading, we want everything less than or equal to, so bracket, 13/8, that's going to shade it that way. Greater than or equal to, so bracket, we're going to shade this way. So we're talking about everything in between. Any number I could pick in between here, if I plugged it in, would give me a true statement. So then interval notation says from -19/8 to 13/8. Closed brackets included. So don't forget, you have to be able to do all of this stuff. You need to be able to get the correct answers. You need to be able to graph on a number line, and you need to be able to do interval notation. All right, I'm going to find a problem on my math lab, then I'm going to share my screen so that you can see it. So if you'll give me 1 second. If I'd already have this pulled up, then my computer being slow wouldn't bother me. But I don't want to show you like the button pushes and exactly what we're looking at here. Come on. Got the spinning circle of death. It won't run. Sorry, I'm really not trying to have all this dead air, but like I'm literally clicking on the button. It's just spinning, like it won't go to anything.
For the My Math Lab,
Yeah,
mine's not working either.
all right. Well, I was gonna show you exactly what to type in, but I'm gonna have to basically, what I'll probably do is I'll just create a separate video for you guys to watch if you want to, and we'll just do it from there. I don't know why this won't load up for me, but this is driving me crazy, and I don't wanna, anyway, I don't wanna have a bunch of dead air on here. So as far as stuff that we need to cover, that basically goes over all of the stuff that you need. So as far as that goes, if you don't have any questions, you're free to kind of check out. Okay. Anyway, like I said, I will make a separate video and I'll walk through exactly kind of what the My Math Lab looks like. So it's just a little bit confusing in how it shows stuff and specific buttons you need to click, as opposed to just whenever you're drawing it or doing it with pencil and paper, it's just so much easier. But anyway, as far as that goes, that's all I was going to cover. Does anybody have any specific questions? Anything you're not sure about? I actually did take roll this time, so that's nice. And Shelby, I got you. So I think we're good. If there are no questions, then I'll see everybody next Thursday.